Hi, this is Mr. Varon with yesterday's April 13th problem of the day solutions. So it says Marty drew a rectangle with the following dimensions: 2 centimeters by 6 centimeters. Part A, what is the perimeter in centimeters of Marty's rectangle? Show or explain how you get your answer. Part B, what is the area in square centimeters of Marty's rectangle? Show or explain how you get your answer. Part C, draw a rectangle that has the same perimeter as Marty's rectangle but a different area. Use numbers to label the dimensions of your rectangle. And Part D, what is the area in square centimeters of the rectangle you drew for Part C? Show or explain how you get your answer. So here are our solutions to our problems. So Part A wanted the perimeter of the rectangle. So in order to get the perimeter, we first had to figure out what all the sides were worth. So they gave us the left side, which was 2 centimeters, and the top, which was 6 centimeters. So if we know our definition of a rectangle, we know that the opposite sides are congruent. So if this side is 2 centimeters, that side has to be 2 centimeters as well. And if the top is 6 centimeters, the bottom has to be 6 centimeters. So there are two formulas we can use for the perimeter of a rectangle. A real simple one that most kids use is side plus side plus side plus side, because the perimeter is the distance around a shape. So if we're thinking about like this maybe being a yard, we would think about the perimeter kind of being the fence around the yard. So in this case, I'm going to add up all the sides. So 2 plus 2 plus 6 plus 6, and I come up with 16 centimeters. Now another formula you can use for a rectangle would be perimeter equals 2 times the length plus 2 times the width. Now we can use this because we know the two lengths are the same and the two widths are the same. That's how we ended up figuring out the opposite sides being congruent. So in this case, I can do 2 times 2 plus 2 times 6. So 2 times 2 is 4, 2 times 6 is 12, 4 plus 12 is 16 centimeters. So the perimeter of our rectangle is 16 centimeters. Part B wanted to figure out what the area of that rectangle is. Now area, the formula for that is length times width. We're really trying to figure out how many square centimeters would fit inside of this two-dimensional shape. So in order to figure that out, I'm going to multiply my length times my width. So 6 times 2 equals 12 square centimeters. You can also write that as centimeters to the second power. Now, Part C and D. Part C wanted you to draw a rectangle that had the same perimeter as the rectangle that Marty drew. So we knew Marty's rectangle was 16 centimeters. Now there's a few different possible options that you could have come up with. So if we are going to draw this, so this would be one possible way. And I've done some math here to show my thinking. So if I make one side 1 centimeter, I know the other side has to be 1 centimeter as well. So 1 plus 1 is 2. So if I take the 16, which is my total of my perimeter, and I already subtracted 2, that means that there's 14 left. Now, since I know both of these sides have to be the same in order to be a rectangle, I'm going to basically do 14 divided by 2, which means each side would have to be 7 centimeters. Okay, or think about what plus itself would equal 14. So in this case, this would be one possible option. Now, here's another possible option. Now, I didn't do the 2 centimeters because we already have one with the 2. That was the one that was given. So now I did one side being 3 centimeters. So if that side is 3 centimeters, this side would also have to be 3 centimeters. So that gives us 6 centimeters for that part. So 16 minus 6 is 10. Now again, these two sides have to be the same. So I can either divide 10 by 2 or think what plus itself equals 10, which in this case is going to be 5 centimeters. So each of these sides are going to be 5 centimeters. So subtract the 10, got the 0. And our last way would be as if I make this side 4 centimeters. This side would have to be 4 centimeters. So 4 plus 4 is 8. So 16 minus 8 gets me another 8, which means these sides also have to be 4 centimeters. So in this case, we've actually made a square, not a rectangle. But again, a square is a special type of rectangle. So therefore, this does count. So again, this would be another possible option. So these would be my 3 different options. And again, I've labeled all of my dimensions of my rectangles. Now, Part D wanted us to find the area of each of these. So on this first one, we are going to multiply the length times the width. So if we look over here, I did length times width, so 1 times 7. So our answer for the first option would be 7 square centimeters. And again, centimeters to the second power would be another way of writing that. If you did option B here, we'd do 3 times 5. So length times width, so 3 times 5 equals 15. So the area of that rectangle would be 15 square centimeters, or centimeters to the second power. And then the third option was our square that we made. So again, I'm going to do length times width, so 4 times 4. So in this case, 4 times 4 equals 16 square centimeters, or centimeters to the second power. So those are the perimeters and areas of those three shapes for parts C and D. Hopefully you got the same solutions, and look for today's problem of the day, which will be posted later on this afternoon. Thank you. Have a great day.